All right. Now we're doing 7Q, numbers which sum of powers of its digits is the same number. This is by Raul BC777, and 90% of people like it. Not considering number 1, the integer 153 is the first integer having this property. The sum of the third power of each of its digits is equal to 153. Take a look. 1 to the third, 5 to the third, and 3 to the third equals 1 plus 125 plus 27, which equals 153. The next number that experiences this particular behavior is 37 with the same power. We're going to write the function this that finds the numbers below the given upper limit h max, and it's going to be inclusive, so it's greater than, less than or equal to, whatever, you know what I mean. That fulfills this property, but with different exponents as the power for the digits. All right. This sequence of numbers, sorted list. Okay, cool. And then here's some cases. There's going to be nothing in any of these to the second power, and then to the third, you just get the list, and then whatever the max is, you just go up the list. All right. So basically for this one, we're going to leave it in regular syntax, and we're going to get rid of this stuff here. And right here, let's declare a result variable. We're going to say let result equal an empty array right there, since we're going to be doing something like this at the end. All right, now that we've got that going on, we're going to do a for loop iterating through all the numbers up to h max, except for not with the ones. We're going to not consider 1. So what we're going to do here is we're going to say for let I equal 2, since we're not going to 1, and we're going to say while I is less than or equal to h max, since it said inclusive right here, we're going to say I plus plus and iterate through every single one of them digits. All right. And then after we do that, what's going on here? This thing forget how to do what we needed to do? Okay, cool. All right, so after we do that, we're going to make a sum variable inside of this for loop, so we can sum every digit multiplied, by the exponent, multiplied by the exponent, or whatever, you know what I'm trying to say. So we're going to say let sum equal, and now we're going to use, we're going to turn whatever the I is into a string, right? So we're going to use this string constructor, which is used to create a new string object, and when called instead as a function, it performs type conversion to a primitive string, which is usually more useful. All right, and that's exactly what we're going to do. We're going to say string, and then inside here we're going to do the I. All right, so we're going to say string I. And now we're going to turn this into an array by using spread syntax, which allows an iterable such as an array or string to be expanded in places where 0 or more arguments or elements are expected. All right, so all we have to do for that, wrap this thing up in some brackets, and then right here say dot 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 right in front of it. And now this is going to be an array of whichever digit of whichever number we're on right now. Each digit is its own element in string form. All right. So after we do that, we're going to use the good old reduce method, so we can do the summing of it. And if you don't know about the reduce method, it executes a user-supplied reducer callback function on each element of the array in order, passing in the return value from the calculation on the preceding element. The final result of running the reducer across all elements of the array is a single value. And also we got to know that the first time that the callback is run, there is no return value of the previous calculation. So if supplied, an initial value may be used in its place. So we're going to use the initial value of 0. So the syntax we're going to use is going to be this reduce. We're going to have the previous value, the current value, and then we're also going to have the arrow right here with the expression, and then we're going to have, after this comma, an initial value. All right. So what we're going to do here is say dot reduce, and then inside here we're going to say prev for previous value, cur for current value, arrow right there, and then let's start on the next line. Actually, right here, we're going to have the initial value so we don't forget at the end. Start on the next line, just so we get some more room for this one specifically. And we're going to say previous plus, and then we're going to turn the current digit back into a number using this unary plus operator, which when it precedes, the unary plus operator precedes its operand and evaluates to its operand, but attempts to convert it to a number if it isn't already. So it's basically just an easy way to do the number conversion. So we go like this, and then we're going to say plus for the unary plus cur, and that's going to turn it back into a number, so we can add it all together. All right, so now that we've got that going on, we're going to say plus cur, and we're going to say to the exp power. All right, so whichever exponent it's in right here, we're going to do it for that power. And now that should take care of that. And now down here, let me just bring this back up, see if we got enough room. What happened? Come back over here. All right, that's good enough. So down here, we're going to say, what are we going to say? If this sum equals I, all right, if it equals the current number we're on through the iteration, we're going to say, what are we going to say? We're going to say result dot push I, all right? So it'll just push it into the array. And it's just going to be, it's always going to be these numbers, whatever order they're in. And there's that. And so after that, we're just going to come down here and say return result. Now let's test it out, see if we're good or see if we're not good. Test it out. All right, good. And then attempt it. All right, that's good. And then submit it. All right. This one right here is using the array.from to make the array. It's got the filter method to filter out whatever the numbers that we're going for, and then it's got an extra little function down here. All right, this is going to be a little hard to explain, so maybe another video, right? This one's using array. It's making the array out of hmax minus 1 to account for the 0. And then it's going to map through, and then it's going to make the index, it's going to have the index plus 2, so because it's starting on 2, like we said. And then we're going to do the same filter thing down here, and it's going to filter out whatever element it's on if it equals if the reduction equals the number, right? And then basically here is just what we did right here, except for different, right? So let's go to mine. Very much like this one in my opinion. Best practice in my opinion as well. And we'll see you next time.